So here is our second lecture. In our first lecture, we had concluded that when a force remains in equilibrium state, or when a structure remains in equilibrium state, it should satisfy certain criteria, which are summation of f of x equal to 0, summation of f of y is equals to 0. These are for equilibrium state, that means equilibrium state of forces. But in this lecture, which is our second lecture, we will see what will happen in case of forces which are not in equilibrium state. But before that, we should keep one thing in our mind always, that each and every forces will have two components, especially the forces which are inclined. It will be having two components. One will be in horizontal direction and another will be in vertical direction. If the angle is mentioned here, that the angle is theta with the base or the horizontal component, and if the force is P, so the horizontal component will be P cos theta, and on the other hand the vertical component will be P sin theta. So we should remember that the component with which the angle is given, it will always be cos theta component. So here we can see the angle is given with the horizontal component, so the horizontal component has been denoted as P cos theta, and on the other hand the other component, which is the vertical component, it will be P sin theta. So let's go through this lecture. Here is our first example. In our previous lecture, we had seen different types of forces also. According to that, this is a concurrent force. That means all of the forces are acting at a certain point. We can see 220 Newton, 170 Newton, 200 Newton, 180 Newton, and 225 Newton, 300 Newton. All of the forces are acting at certain point through a certain point. So it is an example of concurrent force. In our question, it has been mentioned that a particle is under the influence of several forces shown at figure. In this figure, find the magnitude and direction of resultant force of the system. That means when all of these forces are acting at this certain point, here we are asked to calculate the magnitude and direction of the resultant force of this entire system. So it is actually expressing that the force system is not in equilibrium. So as it is not in equilibrium, so the summation of f of x will not be equal to 0. There will be a certain value of summation of f of x, and similarly there will be a certain value of summation of f of y. And using the values of summation of f of x and summation of f of y, and as this force system mentioned over this in this question is not in equilibrium state, so it will be having a resultant force. So we are asked to calculate the magnitude and direction of that resultant force. So firstly, we need to calculate the summation of f of x and summation of f of y, and then using summation of f of x and f of y, we need to calculate the resultant force, which is actually the magnitude of the resultant force, and also the direction of the resultant force. The formula of resultant of resultant force is R is equals to root over summation of f of x square plus summation of f of y square. So here we can see, in order to calculate the value of the magnitude of resultant force, we need to know summation of f of x and summation of f of y first. And similarly, the formula for calculating the direction, which is actually the angular direction, so the expression is theta is equal to tan inverse summation of f of y by summation of f of x. This is simply the formula for calculating or denoting the direction of the resultant force. So let's see how we can calculate the f of x and f of y first. So in this force system, we can see 170 Newton is acting in this direction, and 200 Newton, this 220 Newton is acting towards this point, and 200 Newton is acting also towards this point, and this 180 Newton is acting away from the point, and 225 Newton is acting towards the point, and at last 300 Newton is also acting towards the point. If we consider this whole thing as a force, as a coordinate system, that means we can see that if this is our coordinate, y coordinate, that or y axis, and this is our x axis. So according to the global coordinate system, we know that x is positive rightward and x is negative leftward, y is positive upward and y is negative downward. We will be using this sign convention to calculate summation of f of x and summation of f of y. So starting with summation of f of x over here, so in case of summation of f of x, that means the resultant of all forces in x direction, and also the resultant of all components, that means components of all forces in x direction will be needs to be calculated. So let's see what are the force components in x direction. So starting with this 170 Newton force, so this 170 Newton force, we know that each and every forces will have two components. One is in horizontal direction, that means in x direction, and one will be in y direction. So similarly, this 170 Newton force will be having two components. So the first component of 170 Newton, considering the first component as this one, and the other component is this one, 170 Newton. So as the angle of 170 Newton force is given with this horizontal component, so the value of this horizontal component will be 170, as the value of this force is 170, and the angle is given with this component, so this will be cos theta component. So 170 cos theta, that means the value of theta here is given as 30 degree, 170 cos 30. And similarly, the value of y component will be 170 sin 30. So as we are calculating summation of f of x, so let's deal with the x components first. So we have already written the value of the first component, 170 cos 30, which had arise from this 170 Newton force. This is actually the x directional component, which we have calculated already. So the second force we are going to consider is 220 Newton. So this 220 Newton is acting towards the point, so it will also be having two component as well. So one will be in x direction and one will be in y direction. This 220 Newton force is acting towards this point, and the angle is given with the vertical component, which is 40 degree. We know that the whole angle is 90 degree. This whole angle is 90 degree. So if this is 40 degree, this other one will be 50 degree. So the value of this x directional component will be 220 cos 50 degree. As we know that already, as we have already learned the angle with the horizontal component, which is 50 degree. So the value of this component will be 220 cos 50. So we are writing another x directional component 220 cos 50. And now let's move to our third force, which is 200 Newton. We can see this 200 Newton force is acting away from the point. So as this is acting away from the point and this force is already coinciding with the x-axis, so it will not be having any component in y direction. So it will be having the component in x direction only, and as it is coinciding with the x-axis, so the angle is 0. We can easily see from here the angle is 0 degree. So the value will be 200 cos 0 degree, which is only 200. And as it is acting in left direction, we know according to our sign convention, x is positive in right direction and x is negative in left direction. So as it is acting in left direction, it will be minus 200. So we have already got 3 force components. And now let's see the fourth one, which is 180 Newton. It is also acting away from the point, so it will also be having 2 components. One is in x direction and one is in y direction. So we can see the angle with x-axis component is given as 45 degree. So the value of x-axis component will be, for this 180 Newton force, will be 180 cos 45 degree. So let's write it over here, 180 cos 45 degree. And similarly, as it is acting leftward, according to a sign convention, the value of component's value will be negative in leftward direction. So considering minus for this acting in left direction. Then let's come to our fourth force, which is 225 Newton. Considering this 225 Newton, this force is coinciding with y-axis, so this will not be having any component in x direction. So for that we will write just 0. So we have already got 1 2 3 4 and 5, fifth one. So let's see our last one, which is 300 Newton. For this 300 Newton, it's acting towards the point, so it will also be having 2 components. The angle is given with vertical one, so the angle with horizontal one will be, as it is 50, it will be 40 degree. In total, we know that the summation will be 90 degree. So now the value of x-axis component will be 300 cos 40 degree. As you can see, the force was acting towards the point, and the other components for this force will also be acting towards the point. So while acting towards the point, this 300 cos 40 degree is acting leftward. So according to a sign convention, it will be minus 300 cos 40. So calculating all these values, plugging the values of cos 30, cos 50, cos 45, cos 40, and summing it up, we will get the value as minus 268.45 Newton, which is, as the value is negative, that means the force is acting in left direction and the value is 268.45. Now let's see the values of summation of f of y. Again, starting with the first one, 170 Newton. We had seen that this 170 Newton is acting at an angle of 30 degree with x1 x component. So the value was 170 cos 30 for x component. So while considering summation of f of y, we need to consider the forces or the components in y directions only. So as it is 170 cos 30, the other one which is acting in y direction will be 170 cos sine, as the angle is 30 degree 170 sine 30. We can also write it as 170, this angle is 30 degree, so the other one will be 60 degree. So 170 cos 30 cos 60, the value of 170 sine 30 and 170 cos 60 is same, so we can write any one from these two. So writing it as 170 sine 30, as it is acting upward, according to a sign convention y is positive upward, so it will be plus 170 sine 30. Similarly for 220 Newton, it will be having two components as well. The two components will be, we have already calculated the x component, so the y, now the y component will be in this direction. The angle is 40 degree, it's given with the y component, so the value of this y component will be 220 cos 40 degree. We can also write it as 220 sine 50 degree. Why 220 sine 50? Because we know that as this is 50 degree, if we are using this angle 50 degree, but this angle is with horizontal component, but we need to calculate the vertical one, so as we are using 50 degree, it will be sine 50, but while we are using the angle with the component which we are calculating, it will always be cos component, so we can use either cos 40 or sine 50. So taking cos 40, taking sine 50, let's consider sine 50. So sine 50, here we can see this component is acting downward. According to a sign convention, y is negative in downward, so the sign will be negative. Now for third component 200, this 200 is coinciding with x-axis, so it will not be having any, it won't be having any components in y direction, so considering 0 for this one, so we have considered 0 for this one. Our fourth one, which is 180 Newton, this will be having two components as well. One is in this direction, as this force is acting away from the point, so the y component will also be acting away from the point. As this angle is 45, this component will be 180 cos sine 45. We know that sine 45 and cos 45 is same, so we can also write it as 180 sine 40 cos 45 minus 180 sine 45. As this is acting downward, we have taken the negative sign. Then we are having 225 Newton, which is acting upward. Our fifth force, this is coinciding with y component, so we can write directly its value 225 plus 225 as it is acting upward. Our last one, which is 300 Newton, it will be having two components. As we are considering summation of f of y, while calculating summation of f of y, we need to consider the force component in y directions only. So the y 300 newtons y component will be acting towards this point, which is an upward. So for upward, plus sign, and then the value is, we know that this angle is 40 degree and this is 50 degree, so we can write it as 300 cos 50 degree. But if we want to use this 40 degree one, we can also write it as 300 sine 40 degree. So we can use any one from these two. So here we had written 300 sine 40. Now summing this up, we will get the value as 207.03 Newton. As this is positive, it will be acting upward. So to conclude, we can say that summation of f of x is minus 268.45, which will be in negative direction, and the value is 268.45. and summation of f of y, the value of summation of f of y is 207.03, so it will be acting upward, 207.03. so we can easily assume that resultant will be in between this force, so it will be acting here. So denoting with r, denoting the resultant force with r, the value of this resultant force r will be equal to root over summation of f of x square plus summation of f of y square. We have already calculated the value of summation of f of x, which is this one, and summation of f of y, which is 207.03 Newton. So now plugging the values over here, we will get this. Plugging the values over here, we will get the value as 339.01 Newton. So here we can see that x component was acting in this direction and y was acting, summation of f of y was acting upward, which was 207.03 Newton. This one was 268.45, and the resultant, the value of resultant is, now let's denote it with red sign. So the value of resultant is 339.01 Newton. Now in our second portion, we are asked to calculate the direction also. So we have already calculated the magnitude. Now to calculate the direction, that means we need to calculate the angle at which it's acting. So the formula will be theta is equals to tan inverse summation of f of y by summation of f of x. So the value of summation of f of y was, the value of summation of f of y was 207.03, and the value of summation of f of x is minus 268.45. So from here we will get the value as minus 37.64 degree. So as the value is negative, that means we will need to start from this direction. If the value would come as positive, then we will be needing to start from positive side. Okay, and the angle will always be with the horizontal component, with the horizontal axis, that means with x-axis. If the angle is positive, we need to start from this direction, in this direction, and if the angle comes as negative, we need to go in this direction. So here you can see the value has came as 37.64 degree. That means we need to move in this direction. Here is our resultant one. So the angle is 37.64 degree. So this was all for example 1. We have where we have calculated magnitude and direction of resultant force. Here is our answer. You can see this angle 37.64. Here is our resultant force. We need to draw this figure at last, or else we can just conclude using this figure. Now in our example 2, we have been asked to do the same thing once again, but it's a simplified one. magnitude and direction of the resultant force of the system. You need to try this example too at your home. But the thing I just want to mention is that here the angle is not given, so you can easily calculate the angle from this slope. The slope is given as 3:4. That means this is a rectangle, this is a right angle triangle, this is 3. That means the height is 3, the base is 4. We can easily calculate the angles from here. That means what will be this angle, what will be this angle, this angle, and this angle is the same, will be the same one. So using the formula of tan, that means tan theta equal to height over base, that means 3/4. So from here we can get the value of theta, which is equal to tan inverse 3/4, and this angle will be tan inverse 3/4, which is tan inverse 3/4, which will be 36.86, 36.87 degree. Similarly, you can also calculate this angle, and using those angles you can calculate the components, and using the components you need to calculate summation of f of x, summation of f of y, the resultant force, and the directions. Here the direction is positive, so we can see here that the summation of f of x is also positive, summation of f of y is also positive, so the resultant will be in between these two, which is in this direction. Now as the angle is positive, we need to move from this direction, and the angle will be 62.78. as the angle is positive, we are moving from the positive side of x. We know that x is positive rightward and negative leftward, so we are starting from rightward portion, 62.78 degree. So try this example too at your home. Thank you. This was all from this lecture.